Okay, welcome back, guys. We're just about to do what have we done? 2K, and we're just about to do 2L. Make sure I get that right this time. And 2L is all about odd functions and even functions. Obviously, we're still working on the HL, AA, IB maths course. Okay, so we're talking about definitions here. I've just taken this from the book. It says a function is even if for all x in the domain, minus x is in the domain and f of x equals f of minus x. There's a lot of words there. Get rid of me there. So what they're really saying is that if you put in number, let's say on this side of the axis, so say for example we put in 2, so the pen is not, just change to another pen. So if we put in 2, then we should get the same height as when we put in minus 2. Okay, or likewise, when we put in minus 2, minus 2 is going to give us 2, so it's going to give us the same thing. So a classic one here would be, for example, just take those away. Classic one would be y is equal to x squared, okay, because it's essentially reflected over the y-axis. And that's all this is really saying. They're saying, well, look, if you do f of 5, that should give you f of minus 5. Okay. So y equals x squared would be a good one there to do. We should really put on x and y, and we should put on some coordinate points here. You know, you could put on 1, 1, and so on. Okay, and then it's talking about a function is odd. The definition for an odd function is that essentially this, right? F of minus x equals minus f of x, right? So a classic one here would be x cubed. So, you know, x cubed, you're getting 1, 1, getting 2, 8. And on the other side, you're getting minus 1, and minus 2, minus 8. So in that case, you'll be talking about saying, I don't know, if you said, for example, f of 2 in the function, let's define the function to be x cubed. So we're talking about this one here, of course. So f of 2 in that case would give us 8, but f of minus 2 gives us minus 8. So minus 2 cubed brings us back to the negative again of minus 8. And minus f of minus 2, well, sorry, minus f of 2 there, because what are we talking about? We're saying when x is equal to 2. Okay, so when x is equal to 2, f of minus 2 gives us minus 8, but minus f of x, well, here's f of x, also gives us minus 8 because f of 2 gives us 8. Okay, so basically what we're dealing with here is saying that whatever value we get on this side, when we put the negative of this number in, we'll get the negative of our answer. Okay, and it could have been that I had the graph this way around as well. That also would have been the case if I take the negative. If I say, well, if I take, say, 2 and put it in here, and I get out minus 8, well, in this function, when I put in minus 2, I get out minus 8. Okay, that would be the graph of minus x cubed. Okay, so some other classic functions here would be, for example, the sine function. Okay, just give you a moment to think about whether that's an odd or an even function, or maybe it's neither. And or we could take tan, or let's take the cos function here. Okay, so we take cos function. It's going something like this. Sorry, that's pretty nasty. Okay, and so this is 90 degrees, minus 90 degrees and 90 degrees, or later on you'll be saying pi over 2. Okay, so this first one. And again, we've got here's pi over 2 or 90, here's 180, here's 360, here's minus 180. So you can see in this case, we've got this, the situation where if we put in, say, 90 degrees, we're getting a height of 1. But if we put in minus 90 degrees, we're getting the height of minus 1, the negative of what you have before. So this is an odd function. Okay, and there's also this rotational symmetry of 180 degrees. So it's saying, let's take this, let's spin it around this, and let's spin it 180 degrees either way round. Okay, and you should get this pattern once you've spun it around. Okay, and this one, of course, this is your cos function. So this was, if you wanted, sine x, or f of x equals sine of x. And this is y equals cos of x, or f of x equals cos of x. And again, it's giving us a height of 1 there. And this one, of course, you can see is an even function. Okay, you know, f of 90 degrees, this gives us 0, but f of minus 90 degrees also gives us 0. Okay, so with that in mind, let's have a look at the question. So the question is us to come up with some functions. So it says, determine algebraically whether the following functions are even, odd, or neither. Confirm your answers graphically. Okay, so it's not actually asking us to do this graphically to start off with. So, okay, so first of all, it's kind of interesting that they didn't do that. Okay, so if we say f of minus x, we're hoping to get out for an even function. We're hoping to get out the same as f of x. So let's actually put minus x into this function. And let's say 3 minus 2 lots of minus x squared. We can see that when we square a minus number, that's the same as doing 3 minus 2x squared. And you can see that's the same as f of x, so this is an even function. Okay, so we've found this out by substituting in minus x into this function here. So let's just erase that for a moment. And graphically, this is going to look like a negative x squared graph. So this is negative x squared. If we times that by 2, we're going to get something steeper like this. And if we add 3 on, that 3 could have been put on the end as an add 3, it's going to shift the whole graph up to get to 3 here. So the graph is going to look something like this. And you can do a neater sketch of that one. You can find out where it crosses here and here as well. But a little sketch would be good to justify this graphically. And you can see that there is a horizontal line of symmetry here. So you can say to the examiner, once you've made your nice sketch, saying where all the intercepts are, you can say that my line of symmetry, so your line of symmetry is going to be equal to x equals to 0, in which case it's an even function. By the way, that's me writing a line of symmetry there. In an exam, write it out properly, because the examiner is not necessarily going to know what you're talking about there. Okay, so part B, let's have a look at this one. I think I'm going to start with the sketch. So sketch, in this case, we're saying from 0 to 6, we've got minus x plus 6. If I go to plus 6 here, and we've got minus x, so it's decreasing down to until I hit 6 there. And then x minus 6 for this part is going to be, oh, not really got enough room for this one. Okay, so something like this. That was 6 and 6, and then so minus x plus 6. So when we put in 0 here, I don't know. So no, so we're looking at this part. So I'm getting myself confused here. So this one is going to go through minus 6, but then it's going to have a positive x gradient. So in fact, it's going to go like this. It's not going to go like this, because there's a plus in front of x, so it's got a gradient of +1. So it goes something like this. Now, that's not an even function, obviously, and it's not an odd function, obviously, because we're not rotating by 180 degrees this part to get this part here. So we can clearly see graphically that this is neither. Now, to try and prove this algebraically, we need to go back to this definition, and we either need to show that f of x equals f of minus x, or f of minus x equals minus f of x. Okay, so we need to be doing that with this function for g. You can see I kind of messed up a little bit there, but let's just take that one back. So notice in this definition, that in both of those definitions, you've got f of minus x. So in the top one, you've got f of minus x, and in the second one, you've got f of minus x there as well. So let's have a look at g of minus x. Okay, so in fact, it really depends whether or not we're looking at the first part or the second part, because g of x changes according to what we're looking at. So, but let's just look at it for one of the parts. So let's say when x is greater than, let's say for x is, no, say for the first part, between x is -6 and 0, then g of minus x is then going to be minus x. That's substituting minus x in there, and we're still going to get -6. Now, in nowhere in this function is that defined, -x minus 6. So this is clearly definitely not equal to g of x, but it's also not equal to minus g of x as well. So the negative of x plus 6 essentially, so it's not equaling to, we'd need it to equal to minus x plus 6, and x plus 6 there doesn't exist as g of x either. So this clearly can't either be even or an odd function. Okay, now that's doing it for -6 to x to 0, and to be honest, it's sufficient to do it for that, because clearly if it's not working for one side, it's not going to work for the other side as well. Or, frankly, it just doesn't matter. It's just not, if it doesn't work for one side, it is done. Okay, now that's pretty tricky, I think. It's tricky because we've got the function split into two, but essentially just take g of minus x or f of minus x, substitute that into one of the parts, and see if you're getting out either g of x or minus g of x. And you can see that that's not the case here. Now, where I was messing up a little bit earlier on actually was thinking, actually we can just disprove this with a particular number, but actually it's asking us to do it algebraically. So they really want us to put in minus x and see out what we get, see what we get. Do we get g of x? Do we get minus g of x? Even function or odd function? If we don't get either of those things, then we've got neither an even function nor an odd function. Okay, well, there is another way of dealing with this, though. You could actually use a counterexample. And the counterexample you could choose to be, say, for example, g of, how was the graph again? The graph was like this and like this. So that was up to 6. If we took, say, for example, 3. So perhaps let's take g of 3. And g of 3 is equaling to 3 here. So now let's test. When you do g of minus 3, g of minus 3 gives you minus 9. Okay, so then you can see, well, does this, for an even function, are you getting minus g of minus 3 being equal to g of 3? Well, no, you're not, so it's not an even function. And also, are you getting g of minus 3 equaling to minus g of 3? Well, again, no, you're not, because in that case, g of minus 3 was minus 9, and g of 3 was 3. So you're not, that's not working as well. So this is also not true. That's not true. So this is not an odd function. So you can do this through counterexamples as well, because you only need one value to not work, for it to not be an even function, or for it to not be an odd function. Okay, well, let's have a look at the last one here then. So the last one is split up into two, of course, again, and we've got from -6 to 0 and from 0 to 6. And we've got these two quadratic graphs. So let's just draw a quick sketch of this. And I can see the first one has a root at -6. I'm going to put a root at -6. Again, I'm doing things the wrong way around. I'm doing things graphically first. So we've got the first one that has is a shift of x squared backwards, or in the negative x direction, by -6 units. It's a translation, in fact, it's not a shift, though it is shifting, but translation is what we should say. And if we take this from -6, so though it's going to go something like this, it's actually only starting at -6. We only want that part. And at 0, if we put 0 into this, we get 36 out. So it's going to look something like this. And it's going to hit 36 at the top. and it's not actually including 0 here, so there's going to be an empty circle at the top there. Now, for the next one, we see that we've got x minus x, so this is a shift or translation forwards in the x direction by 6 units for the x squared graph. So it's there's a repeated root at 6, and so we've got a function which is, well, it was going to be something like this until they put a negative in front of it as well. So we're going to need to take this and reflect it over to this side. So again, we're only going to end up with this part. It's going to look something like that. Again, this time we can put a solid circle there as well at minus 36. Okay, so there's roughly your graph. Now, I actually tried to make this a second ago and it was really messing up, but it's fine to mess up your first sketch when you're sort of trying to do your working out on an exam paper. You should just put a line through it and redraw it so that it's has a better scale. Okay, so graphically, you can see that this part here, if reflected around 0, 0, not reflected, rotated around 0, 0 by 180 degrees, either clockwise or anti-clockwise, you can see that you're going to get this section here. I think that's relatively easy to see. I mean, you can check that, of course. You can say, well, check it out. When I put in 3, I get minus 9. And the minus 9 is going to give us 9, which is what happens when I put in minus 3. So we can see it's an odd function. We can verify that. Okay, now algebraically is the trickier thing again. And in this case, I'm going to take when x is what should I do? Take this part here. So let's take this part here and say, well, let's take x to be minus x. Okay, because remember, just check this out again in here. Remember, in the definition, in both of those definitions, we've got f of minus x. So we can start by finding f of minus x, but we're trying to work towards minus f of x here. So if we take this thing here, if we put minus x in, so let's do minus x plus 6, we're hoping that that's going to give us out minus this thing on the other side. Okay, so what are we talking about? Let's see. So we're saying that this is putting in minus x. Now we can see that that's not looking like the negative of this thing at the moment, but what we could do here is times the inside by, take a factor of minus 1 out of the inside here, split this into 2. So we've got x minus 6 inside. So I was just struggling a little on that one. So we've got x minus 6 on the inside now. So I've taken that factor out. And if we square both parts there, well, we'll see that this is the same as x minus 6 all squared. Okay, now that's equal to h of x for that second part if we put a minus in front of it. So we're now showing that if we take the first part and replace x by minus x, then we end up with the other side, what's happening on the other side of the y-axis with a minus in front, so negative of this thing here. Now, since we've shown it to be true by taking these numbers to get to the answers on the other side, so we've taken all of this and shown it to be true to give us the negative of all of these answers on this side, so it's also true the other way round. Okay, now let's just have a look at what they're saying here, because I'm not totally happy with my explanation. Let's see what they're saying. They're saying for x is between 0 and 6. Oh, they've taken the positive x numbers. Okay, so they've actually taken the second part of the function. Let's have a look at that. They've taken this, and they've put in here x of minus x in this section. So they've said, okay, well, I can see that that's minus x minus 6, and there's a minus in front. all I've done is replace the x with a minus x there, and then they've squared it. And again, if you take out a minus 1 there and square it, you're left with plus 6 squared, and you've got a minus in front there. And that's the same as minus x plus 6 squared, which is the same as this function with a negative in front of it the other way round. So they've just done it the other way round, but how I've done it. Okay, so that's equal to h of minus x for the other section. But again, it's sufficient to do this for one side to get the other side. Now, what I am missing is I didn't specify my domain. So I really should have specified my domain here, and I should have said I'm looking at from 6x to 0, so from minus 6 to 0. So I'm choosing this, and then since this is true, comma at the end, comma between 0 and 6, then we have an odd function. Okay, and if you have a look, they've kind of done that as well, though they haven't defined the second domain for minus h of x there. Okay, now I'm kind of doing a little bit too much there, but I really think in these piecewise functions, where we're both dealing with piecewise functions and odd and even functions, that becomes really quite tricky. So, you know, so I would suggest just defining which part of the domain you're looking at in order to get the other side. Okay, right, so it's an odd function, and good, we're there. Exercise 2L, not many questions here, of course, so make sure that you're getting the maximum amount of practice. Okay, guys, well, thank you for listening there, and that's me done for the moment. See you next time.